that this horn antenna is also connected in a horizontal manner. Okay, so in this horn antenna, if you see, there are these two things. One is nothing but this is A part and the other one is B part. Okay, so this is going to be the length of the horn antenna, and this is going to be the breadth of it. Alright, now so here if you see here, the dimension of the antenna, if you will have to take it, so take the A part. Okay, using the scale, you can just take the A part of it and then take it as your dimension of the antenna. Alright, not necessary that all the dimensions will be the same. It differs from one horn antenna to another horn antenna. Okay, so this you can keep it in the transmitting end. Okay, and it has two planes. One is nothing but the H plane and the other one is the E plane. So you guys know, if you have to find out the radiation characteristics of any antenna, we will have something called as a radiation pattern. Am I correct? This one is nothing but a radiation pattern. This one. Okay. So since it has two planes, we should make sure that both of these transmitting end of the antenna as well as the receiving end of the antenna is in one particular plane. Okay, if at all my A is parallel to the ground, okay, so this is going to be in H plane. If my A is perpendicular to the ground, it is going to be in E plane. Okay, so wherever you are keeping the transmitter end in the H plane, even your receiver part also should be in H plane. If that is in E plane, both of the signal gets cancelled out and you will get 0. Alright, yeah, so what we will have to do here is, after the mode 1, you place this in H plane, and then from the transmitter end, from the receiver end, you place it something like this, okay, and then, this is an E plane, right? Yes. You have to make it to H plane, okay, and then you take the probe from here to the CRO and find out the power readings for the same. Very simple. This is the one. Similarly, you are supposed to do it for E plane. Got it? Yeah? Now, how do you find out the distance, what has to be there between the transmitter and the receiver? Okay? So, the distance is nothing but 2d square by lambda. Okay? So, lambda would be what? C by F. Yeah? F is what? Mode 1. You will find out what you will find out? Peak to peak value as well as operating frequency. That frequency you add. Okay? So you got lambda. Lambda is equal to C by F. 2d square. D square is nothing but, D is nothing but the maximum dimension of the horn antenna, which is nothing but the A. Okay? So if you find out the maximum dimension is going to be 10 centimeters. Alright? Now, and then you will get a value of D, somewhere around 70, 80, something like that you will get. Okay, so how will you hold this now? Hold it here. How will you calculate this? Okay, from here, okay, till here. From this point till this point, you are supposed to calculate the value of D. So that is the distance between the transmitter and the receiver you are going to keep. And then what you are going to do is, you are going to rotate this. There is a stand over here. Make sure that this is at 0th position. Okay, and then from here, see here. There's a black knob over here, and you can find it out. Can you see this blue color point over here? I keep this at the 0th position. Now it is in, make it as, yeah, H plane. Okay. So this is an E plane. Okay. So you move from 0 to 35 degrees right, 0 to 35 degrees left using this. Okay, in E plane, and the same you are doing it in H plane also. Okay, so that is what you are going to find out over here. Understood? So after you find out, there are this radiation pattern which you have to draw it in polar graph. Alright, so once you get the points for this, okay, you have to plot these values in a polar plot. Polar plot is nothing but it has the power in decibels. And for the degrees, 0 to 35 and 0 to 35, you will get it in right as well as left, and you get something like a pattern. From the polar graph, how you have to calculate theta value, I will tell you that. But you plot it and come in the next lab. Understood? Yeah? And now if you see that part of, can you hold this map? Now this part is called as a twister. Okay, this entire thing is in H plane, but I have to keep this in E plane. So what I'll do, I'll make use of a twister and keep it in E plane. This is only for E plane. Otherwise, H plane directly you can connect. Okay, while you are after connection, transmitter, the distance and all those things, then you switch on the HT to on and then calculate the values whatever you are going to get for 0 degrees up to 35 and from right and left.
Beam value 250
so again it should be maximum, Rappler is maximum, beam is minimum, okay, and then make the beam to 250, then start reducing the Rappler. Once you get the highest one, it would be mode 1, okay, and then you can start your experiment. Once you get the highest one, make sure take the dip, operating frequency of the same, and then get back to the same highest graph and then HT off. Understood?
Yes, ma'am.
Yeah? So 3 of them can be here, 3 of them can be there, and just finish off this experiment.
The main aim is to find the range of the horn antenna, right? How much
the radiation pattern of a horn antenna.
Okay.
So when you see the
So it's not how much it's capturing and
how much it is?
how much it is capturing, so it's changing the angle.
Yes.
Right?
Basically the transmitter end, receiver end, how much of radiations is being captured by that particular horn antenna, that we are going to do it as a graph which is called as a radiation pattern of it. So this is going to tell, this is called as the major lobe, and this is going to tell us how much the radiation can be acquired by that particular horn antenna. Okay, since it has 2 planes, we are going to get 2 different planes of radiation pattern.